Welcome back to Learning Solidity. Now, I know it's been a while since my last tutorial. I've had quite a bit going on in my life, so finding the time to actually record these videos has been a little bit difficult. What I'm going to try to do is I'm going to try and make the time at the moment to try and add some more content to the Learning Solidity tutorials on YouTube and as well as my GitHub. Now, you may have noticed about 3 or 4 months ago I released a tutorial on my GitHub repository which was tutorial 28, but I didn't actually provide any YouTube content for that. Now essentially this was the tutorial 28 address book on the blockchain powered by Angular. Now I actually wrote this tutorial back in February, but because I didn't have the time to record the video, what I did was just release the source code for the tutorial and essentially just a README MD file. So you had like a little bit of an instruction on how to actually get up and running with something quite simple with the blockchain, with MetaMask, and with Angular. Now, essentially what you see in front of us is the application that we're going to be looking at today. Now, I'm not going to be doing too much coding in this tutorial. This is simply just going to show you how to get up and running with this and essentially just what it is. Now, obviously, with Solidity, and with the Ethereum network especially, is that we have this concept of addresses, and often these addresses don't mean anything to us. It's like with telephone numbers. Someone can't read a phone number out essentially and you know who it is instantly. You possibly can with some certain numbers, but trying to remember just numbers and letters in a random order is just convoluted. So for instance, if you wanted just a list of people that you pay frequently on the Ethereum network, this is a great way or a great stepping stone to doing that. So obviously you've got your storage of your addresses that you could obviously then expand the functionality of just paying your predefined addresses, and you know essentially who you're paying. So when you actually kick the application up, and obviously I'll show you how to get all that up and running in this tutorial, you're basically going to first see this Learning Solidity tutorial 28 address book on the blockchain. Now you're going to see a very basic sort of page with 2 buttons in the top right hand corner, one home, one address. This is the home page. If I click addresses, we can provide an address and provide an alias, and obviously this is a way that we don't have to remember these long addresses like this, and we can bind an alias to them. So for instance, this first address I'm going to say is Bob, and then I'm going to add that to my address book. We're going to have MetaMask pop up to tell us that we're going to make a transaction on the network. We're going to confirm that, and then that's going to appear in our addresses. We can see that the transaction has now been confirmed. What I do is I actually, in this application, I don't wait until the confirmation has come from the network. What I do is they just cache it essentially, rather than have it linger around and load and so forth. And the next thing we can do obviously from there is we can add another address. We can then say this is Alice. We can add that to our address book as well. Obviously we're going to get another confirmation from MetaMask to say we're again executing a transaction on the network. If you wait a couple of seconds, we'll see our transaction has been confirmed and is now valid on the network. This is just a very simple JavaScript and HTML page. So if I were to refresh the browser, for instance, go back to my addresses, they're still persisting. Now the reason they're still persisting is because we're calling that data from the Ethereum network, which allows us to basically have this address book on the actual blockchain network, but allows us to interact with it from our browser. So I now have this permanently stored on the blockchain. Right, granted, this is the test RPC or a test Ethereum network we're storing it on, but the concept applies that it would work in the real Ethereum network and the real Ethereum RPC. So with that being said, let's start looking at getting this up and running. Now we have the ability to add and remove addresses, as you see here. So the address, any sort of interaction with a modification requires us to make that confirmation, and then creates obviously a transaction that needs to be confirmed and so forth. Any sort of simple gets doesn't. The reads on the network are very cheap. So that's in essence our application. Now to get this up and running, let's start looking at the prerequisites. So we need a test RPC. Now I've always used the test RPC on the command line before, which is always a bit clunky and not great, and for most users it's a bit daunting, especially if you're not used to command line interfaces. So what we have is this tool called Ganache. Now Ganache is a great little tool. It's essentially just the test RPC in a nice pretty wrapper that allows us to see various bits and pieces that's going on in the network. So we have first this page of all our addresses on the network. As you can see, this is the first one that I've been using here. You can see the transaction count that I have against that. You can see the very basic things such as the RPC servers running on this. There's, you know, the network's being mined. This is the network ID, gas limit, so forth. You can see all the blocks on the network that are either that have been processed or mined or waiting to be mined. You have all the transactions that you can obviously dive into if you need to do some further debugging, and then you have the logs of the entire network, which is fantastic for when you're actually debugging and testing and diving into your applications. Okay, so to get up and running with Ganache, we have to first set this up to work in harmony, in essence, with our MetaMask. Now, in my previous tutorial I did show something quite similar. So when you first start up Ganache, click on the little cog icon in the top right hand corner, which will bring up the settings. Leave everything as default apart from the accounts and keys. Turn off the key that says, turn off the little flag that says auto generate HD mnemonic. Now what we need to do is create a mnemonic that is going to work in harmony with our MetaMask. So when you boot up MetaMask, you can either do it through the little plugin icon up here, or if you press that button, what it'll do is it'll open it in a separate tab that we can interact with. So what we need to do is specify that we're going to be using the localhost 8545 network, which is our test RPC network. Now I've just created an account with MetaMask, and it's just simply test. I don't use it with the live network, so it's just a very simple thing. You can see the transactions for my account. So obviously in this scenario, I'm already bound to the network using that mnemonic, so I have all the information available to you. You might not have it at this point, so if you don't, what you need to do is click on the little icon in the top right hand corner, go down to settings, click on reveal your seed words, enter your password, so test. Take your seed, paste it in mnemonic, restart, and then once you've done that, go into your settings again, reset your account, log out, log back in again, make sure you're on the private network, and hey presto, your MetaMask and your Ganache, or your test RPC in this case, is basically just going to work very, very simply. And you should obviously, when you've logged in, you should have this account, which is a reflection of this first account on the network. So you can see we've got 99.88 Ethereum here, and we've got 99.87 here. Obviously it's rounded, but it's still, everything's now working in conjunction with one another. So that's just a simple way of setting up Ganache and MetaMask. So now we have Ganache and MetaMask set up, what we need to do is get our smart contract set up. Now our smart contract is very simple. All it is a file which is located in Solidity, Solidity contracts address book. Now this is all it is. Why has it done that? Because I don't know how to move files. Let's just close all these other tabs. Now all we do is have 5 simple functions in this. You can go ahead and just ignore this state. I was using it as sort of a prototype way of being able to cache a state in a cookie, but I never actually got around to completing it, and I never got around to removing it, so ignore it for now. So we only have 2 variables that we need to be aware of. Addresses, which is a map of an address to an address array, and then aliases, which is a map of addresses to another map of an address to a string. Now all this is that is your user or your address that's going to have a set of addresses stored against it, which is in essence your address book. But obviously, like I said, having the 1, 2, 3 ABC doesn't mean anything to you, so you need something to associate that to. So this is your address, which is going to be a map of an address, which is the addresses stored in here, and those addresses are going to be mapped to strings. Now this, I felt at the time, was the easiest way to store that data structure in Solidity, so I can iterate over this address, pull out all the strings, and essentially you have that that key pair value sort of storing mechanism that's easy to iterate over. The first function we have is the get addresses that simply just returns the array of addresses for your specific your specific address. The next thing is to add an address. What we simply do is we take an address you've passed in plus an alias. We then push that address to the list of addresses, so it will be pushed into here for you. And then we also set the alias for this, so it's for your user, for the address you specified and the alias you specified. Then we increment the state, but that's what is essentially that caching mechanism I was talking about before, but we'll ignore that for now. The remove address, a little bit more complicated because we've got to change the size of arrays and so forth. So, and we also have to essentially clear up any aliases and whatnot. So what we do is we first find the address, get the list of addresses, or the length of the addresses that we're going to be iterating over, do a for loop based off that length. If the address that we're basically saying to remove is equal to the address of you plus the ID of the first iteration of that that loop, if it matches, what we need to do is make sure that the length isn't less than 1, because if we're going to be rejigging stuff around, for instance, like decrementing the length of the array and whatnot, or reordering the array, this is going to cause a little bit of a problem. This function also allows us to maintain the sequence order of the array too. Obviously there is a way of just popping something out of an array and whatnot, or just reshuffling things around, but it's a little tricky. So what I do is I basically shift the last element of the array to the position of the thing that I'm removing if it is less than 1, or the length of the array is, or I is less than basically the end of the array. Then I delete the thing that we've just swapped from, or essentially just swapped from, or more specifically, if it's the case, the last element of the array. I decrement the length of the array, so by 1. I then delete the alias for it, and then obviously I've updated the state, so I need to increment that. The next thing we do is we get the alias for a specific address, where we simply just look in the aliases for your address, where the address is the one that you've specified in, which should return the string or the alias. In this case, if it was doing x321 was Bob, we'd pass x321 in there, it'd be associated to your address, and then just simply return Bob. And then finally the get state function, which again is the thing we're ignoring because it's just a way of I used to store cache. Now to build this, all you simply need to do is make your way into, let's terminate that, the Solidity directory. One thing you've got to make sure that you've done, if you've already built this before and you're redeploying it and testing it, delete the build directory. I've noticed that if you don't delete the build directory when it deploys it to the network, I think it causes a conflict somewhere and you get into a little bit of a mess. So just simply rm the build directory. Yeah, get rid of everything there. So we don't have a build directory. So when we do a migration, it's not going to cause us any problems. Now to migrate this, we simply call truffle migrate. If you bear with it a moment, it will then deploy it to the network. Now this is deployed to our test RPC network. Now with the deployment of it, what we need to do is take two things from the deployment. The first is the location that the address just got deployed to. In this case, it's this one here. And the second is our ABI, our application binary interface, I think it is. Let me just double check that before I'm actually quoting the wrong thing. Solidity ABI. ABI. Let's see if I am right. Contract ABI. Application binary interface, yes. It's basically a way of us defining what our smart contract is, what it can do, what it takes in, and what it will return. And that's all an ABI is. We have our ABI stored inside the build directory in contracts and in a file called addressbook.json. Now you notice inside here there's an object, and inside our nested object we have our ABI. So what you need to do is take a copy of that and move it up to your address book within your web application. You don't need to do it if you've not modified it. All this does is basically allow our web application to know how it can interact with the contract, but I'll go into that in a little bit more detail. I'm just trying to cover how you basically get set up and going. Obviously the next thing then is to take the address the smart contract has been stored as, And in this case, we need to just make our way into the controller's addresses and paste it here on line 12, which is how we basically set up our address book contract interface. But I feel like I'm diving a bit too much into the depths without covering the basics. So that's essentially everything in Solidity that we need to know and cover. Deployed, we've got a smart contract built, it's deployed on the network, we have the address, and we have the ABI. The next thing is let's get started with our web application, which is probably why a lot of people came to view this tutorial. So we've covered, we've basically got a few things in here. For the life of me, I can't remember why I included the Napa library for JavaScript, but I'm frightened to remove it just in case it breaks something, so I've left it in for now. All we've got in here is some basic stuff. So we've got Ethereum.js contract, and we've got Ethereum.js query. These are the two things that will allow us to interact with the Ethereum network and obviously define our APIs. Therefore, granted, your interaction comes from MetaMask, but obviously it defines how we build our calls to MetaMask, which is obviously then passed on to the network. And then we have that basic grunt things. So grunt obviously allows us to sort of like have a management of our application through our grunt file. Browserify, which is, if I remember rightly, the minimizer. It's been a while since I've looked at this project, so you have to bear with me if I'm making a mistake here. And then you have some just basic things such as JS hint, so a linter, and also a watch, which watches a directory for any changes. So if changes made, it rebuilds the application and deploys it. And I believe connect is the application that serves it. But I won't go into too much detail because I think I might be mistaken. Either way, that's everything set up for now. Obviously, I think it's the package manager for Napa that I needed so I could get the Angular requirements. That's why I use Napa. I do remember now. If I would have removed that, would have broken it. So we use Napa here just simply to define our requirements for Angular. In this case, we're just using a basic Angular and Angular root. So it's basically simple power installation. Now in our grunt file, we have some quite simple things. We have our definition of browserify, which is a source. It's the minifier. I was right. So it's basically taking the source from our source directory, which is this one here, moving it up to our build directory. And now, if I'm right, has this got a minified version in? That's not really minified. It's just kind of everything chucked into the same file. Similar. Anyway, it's a compiler for JavaScript. I just don't think I basically defined it or set it up that well. The next thing is our JS hinter. So it's basically just a linter for JS, and we're just basically saying that we're using ECMAScript version 6. A copy command, it's so when we make modifications or so forth to our source, it copies everything from that relative path inside source to build, but it'll only copy HTML and CSS. We've got a watcher, so if anything happens, what it does is if anything in source gets changed, it'll run the hinter or the linter, then the minifier, then the copy. So what it'll do first is run this, and then this. After that, we have our connect, and all that does is allows us to serve the contents of build on the local address, localhost port 8000. And then all we do is just register all our tasks and so forth, and then we have the default task, which will basically run this sequence of tasks, and that's what allows us to simply in the command line type grunt, and it will serve everything for us. So that's the basics of the project setup that I've got covered. Let's have a quick look at the application itself. Now, when you first start with this application, you will probably end up in either the index.html, which is our basic template. I probably haven't set this Angular project up as overly well. This was just a very simple concept just to show you how it's how the Ethereum network can interact with the browser, and then obviously the browser using sort of frameworks like obviously Angular in this case, or possibly even React, but I haven't covered that in any of tutorials yet. So we have our simple template, but the main thing that we want to start with is this app. No wait, I'm in the build directory. Let's just go down to the source directory. So let's just collapse everything down. So yeah, so we have this basically this structure inside scripts. We have our app. Now let's just close some of these other tabs so we don't get too confused. What we do in our application is basically saying that we require Angular, we require the controllers, and we require the factories. So inside factories and inside controllers is just a list of all the controllers that we're going to use. So inside source scripts controllers, we have controls.js, and this is a list of all the controllers we have. And then also in source scripts, factories, and then factories.js, this is just a list of our factories. So in our app, we're basically getting all the dependencies that we require. We are then basically loading these modules. So we're loading all the controller modules and we're loading all the factory modules. We're then setting up our routing. And in this case, all we're doing is basically when you arrive on localhost :8000 and /, you will be taken to the templates home.html. But basically, because we have our index.html, this is our wrapper. And in our wrapper, we should have, if I can find it, our controller somewhere. Am I looking at the right thing? Templates. Class container. Here you go. So basically, when we specify a controller or a view, what happens is this ng view is what's going to be replaced. So if I jump back into the app, so the template URL, this template URL home is going to be set in our ng view here. So in this case, it's just going to be home, where you're going to see the welcome to the Solidity address book demo, which is what we saw when we first opened the sort of the demo application. Then this is essentially just going to be bound to our default controller, which, if I'm correct, I only set up one controller for that, which was addresses. And all I do is I just basically swap out the views rather than swap out the controls, which I know you can do within Angular, but I'm not going to jump. This isn't really a tutorial on Angular. This is just a demo of interacting with blockchain from Angular. So inside our controller, we have another route that we also have defined, which is essentially addresses. And in our addresses, we also have basically a template URL, which is the addresses.html, which is going to replace the demo view when this controller is loaded. So anytime you access the URL, which basically finishes with /addresses, we're going to use this template. We're going to override any controller with the address controller, and then that is essentially how we're going to do our navigation. So let's dive a little bit into the address controller. Now we're going to load some basic things. We're going to load the scope, this object called, or this module called Ethereum contract, and that is pretty much it. So let's have a quick look at Ethereum contract before we go any further. Now Ethereum contract is derived from the factories, if I'm correct. Now inside our factories, we load this Ethereum factory, and inside this we have our Ethereum contract. Now inside our Ethereum contract, what this does is it loads the requirement of Ethereum JS into Earth, loads the requirement or the module Earth.js contract into Earth contract, and then returns an object of basically of our implementation. So we have our contract, which is return function, which requires an ABI, which is our application binary interface, an address, and from those two basic calls, we create an Ethereum content provider or current provider in this case. Then we create a new Ethereum contract based off our provider. Then from our contract, we specify our AIB and the address it's located at. So when you return this, what it does is it does a little bit of magic in the background, shall we say, that returns us an object that we can interact with just as if we were interacting with the address book contract itself. So let's just bring that side by side and we can see how we actually interact with that within the Angular controller. So let's close that a second. Let's bring up the addresses. Where's that gone? Awesome. Addresses.js. Okay, let's just close the tabs. So what we've done is we've called Ethereum contract, we've passed in this contract, this API for the contract, which is the file located in the addressbook.json. So we're basically stating, okay, for our contract, we're going to adhere to this ABI. So everything defined within our ABI is the constraints of our object. This is the address, which is where the contract is located. We are then, from our address book, we have the ability to basically then interact with the standard functions in here. So as you can see, there's some stuff in here that I'm not entirely sure is needed, and I think I might have just left it in. No, I do need some stuff in here. I basically just needed this this instance of the Web3, or the Web3 provider in essence, so I can call simple things such as get me an address for my address or something like that. So as you can see, we're making a call to add addresses, which is going to be referenced to this point here in the code. So as you can see, we can just simply state add addresses, which will call this function down here, add addresses, which is going to reference the address book object. And in the same way, we're going to be calling add addresses with our address, which is going to correspond to the address parameter here, the alias, pardon me, which is going to correspond to the alias here. And then you finally have parameters. Now the reason we have parameters is just to state I'm going to be calling this contract from a specific address and with a gas limit. Pardon me one moment. Dry throat. Okay, so that's kind of why we needed the instance of the Web3 provider, so we can get the current address that you are interacting with the contract from. Sorry, the gas limit that we can interact with the contract with. So obviously we don't want to exceed this, I think it's 3 million. Yeah, 3 million gas limit. And then obviously we can make calls to our contracts through these very basic functions. Now, what you may have noticed is I've got these calls to scope.add, scope.remove, and scope.getAddresses. This allows me to call these functions from within our templates. Sorry. So, as you can see in the first call, I'm adding an address which will mimic the add addresses here. The remove, which is obviously the mimic of the remove address. The get addresses, which is the mimic of the get addresses. And then finally the remove addresses. The remove address. No, that should cover everything because I only need those three functions. Get addresses, add, and remove. Don't need anything else after that. There is a call to get aliases, but it is part of the get addresses. So for instance, in the get addresses, what we do is we get all the addresses, which is this call here. Then we loop over all the addresses that's returned to us. And then for each of the addresses, we then get the alias for that address. It seems a bit of a bit heavy interaction with the network. And it probably can be if it gets a bit too big, but this is just a very simple concept. So what I've done, this is what I was previously mentioning, is that I've created some scope for these. So I've added the add, remove, and get addresses to the scope of the controller. And because it's in the scope within our templates, we can then make these calls via the Angular the Angular attributes. So for instance, we have just some basic things like when you click on the get addresses or the refresh button, what it does is just call the get addresses, which will call this, which in turn will call this function, and then in turn it will call the contracts get addresses, and then so forth and so forth. We've also added some basic form implementation and integration with that as well. So when you create or add an address, when the form's submitted, it's called this add method. And we basically pass in the scope that's set from the two input fields, which is the address and the alias. So that's the scope. That's basically what scope address is, and that's what scope alias is. So those two form inputs get mapped back to add address. Then from there, it calls the add addresses function, which is defined down here, which then calls the contract directly with the add addresses, adds the address, the alias, and then passes in the parameters, which again is the address we're calling it from and the gas limit. Then from there, what it does is it adds it on the client side. So in Angular, we're adding the address and the alias to our local cache, which is why it appeared instantly rather than waiting for the transaction to confirm. And then from there, we should have a list somewhere, which is here, or a loop, sorry, should I say, which is here, that allows us to basically iterate over all the elements within our addresses that we cache locally, which is in this case a reference to this. This addresses is what this scope.addresses is, and then a loop over, pull out the key pair values as the key being address and the value is alias. So when it actually iterates over them, it prints the alias and address out with the delete button for that address as well for every element that is within our addresses. Now that in essence is pretty much the implementation in a nutshell. The remove obviously is just simply a callback to the remove function. I don't think I've missed out too much there. I did implement the get state and the get aliases, but I don't think that's used too much outside of the scope of the other functions. So for instance, this get aliases, we'll just simply call this get aliases down here. I did the get addresses when you first load the controller, so on the default page load it gets all of the addresses you've saved in your address book. I've covered everything in the controllers. I gave a very basic overview of that. All that essentially is doing is returning an object, and inside that object is returning a function. Inside that function you pass it an ABI and an address, and it then creates a contract from that. Covered the factories, covered the app.js. Not really much to cover in regards to the style, and then that is pretty much everything for the tutorial 28. So now with everything set up, obviously I can go back into the public directory, run grunt, bring my browser back up. I've still got my my Bob still stored on the network, even though the application came down and came back up, because it's loaded from the Ethereum network. You almost have no reliance on needing an infrastructure to support this. You have pretty much almost 100% uptime based on the amount of nodes available to you locally for the Ethereum network. This makes it a massively redundant application. So this is the power of the Ethereum network. Massive redundancy. So if you don't want to rely on certain things and you want co-located servers and so forth, that's kind of what the Ethereum network allows us to do. And the thing is, you don't need big powerful servers to do the basic things that I'm doing either here. You could run this on a bog standard micro instance at Amazon. All you need to do is serve some HTML and some JavaScript, and then the rest is handled by the Ethereum network and the client side. So everything here is basically is stored in the cloud, so it's something that you don't need any heavy processing for. And that in essence is our tutorial for today. And I'm going to wrap it up there because again I somehow managed to drag these out a little bit longer than I expect them to or plan them to. The next set of tutorials I would like to look at more of the changes to Remix, potentially start looking at Solidity 0.5, and also look at the changes in the Ethereum network overall, and look at some more of the tools, of the development tools that have come out since my original set of tutorials that make everyone's life a little bit easier. Now I hope this wasn't me droning on too much today and you actually got some insight. I'll do a little bit more interactive coding tutorials as time goes on. I want to make them a little bit shorter. This one was a bit drawn out because I had a lot to cover, especially seeing as a lot of people who would be watching this don't have that Angular knowledge and so forth that a lot of people require to actually get Angular applications off the ground. If If you do have any questions, drop them in on my GitHub. I'm going to try and be a little bit more active on that in the near future. So again, just drop any questions, pull requests, I will review. I'm trying not to update the GitHub repository too much with a lot of the changes that I've seen people put on as pull requests, such as fixing old code to be more modern. This kind of defeats the point. Those tutorials were aimed at Solidity 0.4 with the old styles and standards, and I know there is new styles and standards come out, and I'd rather address them going forward in newer tutorials. So that's going to wrap it up for me today. I hope you did find this tutorial somewhat informative and interesting. If you have any suggestions, if you have anything you'd like me to cover, again, just drop a comment in the YouTube comments, chuck it on the GitHub repositories comments. For the most part, I do read them. Sorry if I'm not replying to them as much as I can. Like I say, my time is a bit stretched at the moment, and I'm just trying to find what little time I can to do these. But either way, I hope you enjoyed it, and I will catch you next time.